Two identical trusses support a load of 100 Newton as shown in the figure. The length of each truss is 1 meter, cross-sectional area 200 mm square, Young's modulus E equal to 200 GPa. The force in truss AB in Newton is. So this is a diagram that is given to us. Now when we look at force analysis for trusses, we do not require information like cross-sectional area, Young's modulus, etc. So this all information is just given to confuse you. You need not pay attention to that. So we'll have three forces at this point. So we can apply Lami's theorem for this question. So we'll take joint B. This is 100 Newton. Now to apply Lami's theorem, one of the conditions is that you should have all the forces which will be either towards the point or away from the point. Now we already have 100 Newton which is away from the point. So we'll assume these two forces to be in this direction so that all the three forces become away from the point. So to complete the diagram, we have this. So what we have done is we have assumed that the internal forces in members AB and BC are in these directions. So here we will have, this is force in AB and this is force in BC. Now looking at angles, this is 30, this is 90. So this total is 120. So this angle is 120 degrees. Similarly, this is 30 and this is 90. So this angle will also be 120 degrees. And out of this 360, 120 and 120, 240 are gone. So this also will be 120 degrees. So here we are looking at a special case of Lami's theorem where all the angles are equal. So if all the angles are equal, all the forces will also be equal. So force in member AB will be equal to this 100 Newton. So the answer will be 100. A two-member truss ABC is shown in the figure. The force in kilonewton transmitted in member AB is. So this is a diagram. You have to find out force in this member. So once again we have three forces at point B. We can apply Lami's theorem. So we will be applying Lami's theorem at point B. We have 10 kilonewton which is given to us, which is downwards. Now to apply Lami's theorem, we will take the direction of forces either towards the point or away from the point. So we already have one force which is away from the point. We will take these two to be in this direction so that all the three forces become away from the point. So we will complete the diagram. So these are the directions of internal forces that we are assuming for members AB and BC. So we have force in AB which is in this direction and this is force in BC. Now looking at angles, so if we join this is 90 degrees. Now if we call this angle as theta, then theta will be tan inverse of 0.5 upon 1 which comes to 26.57 degrees. So we have this angle is 26.57 degrees. Now FAB is horizontal, this is vertical. So this total is 90 degrees, out of which this is 26.57. So this will be 63.43 degrees. And this is 90. So from total of 360, if 90 is gone, the remaining is 270. So this angle will be 270 degrees. Now by Lami's theorem, you have to find out force in member AB. So we'll write down FAB upon sine of. Now what happens is many times students remember this as force upon sine of opposite angle. But if the situation is something like this, the opposite angle can be confusing. Actually the theorem is every force is proportional to sine of angle between the other two forces. So when you are considering FAB, we have to look at angle between forces FBC and 10 kilonewton, which is 63.43. So for FAB, the angle will be 63.43. So we'll write down FAB upon sine of 63.43 will be equal to, you have 10 kilonewton which is known force, 10 upon. Once again, when we look at force of 10 kilonewton, we have to look at angle between the other two forces which are FAB and FBC. So the angle is 26.57. So here we'll write down sine of 26.57 degrees. We need not write down the third part which is for FBC. We can solve the question with the help of this equation. So we have FAB will be equal to 10 into sine of 63.43 upon sine of 26.57 degrees. On calculation, this turns out to be 20 kilonewton. So we get the answer will be 20 kilonewton. A two-member truss PQR is supporting a load W. The axial forces in PQ and QR are respectively. So a very similar looking question to the question we have just solved. This is a force W which is given to us. We have to find out forces in these two members. So once again we will have three forces at this joint. So we can apply Lami's theorem. So we'll apply Lami's theorem at joint Q. We have the given force W, which is downwards. So once again, for applying Lami's theorem, we'll assume the forces to be either going away from the joint or towards the joint. So we already have one force which is away from the joint. We'll take the other two also away from the joint. And we'll complete the diagram. So we are assuming the internal forces to be in these directions. So we have assumed FPQ to be in this direction and FQR to be in this direction. Now the angles are already given. This is 30 degrees. This is 60 degrees. So the remainder will be 270 degrees. So now when we apply Lami's theorem, so by Lami's theorem, what are we going to have? FPQ upon sine of. So when we look at FPQ, it will be sine of angle between the other two forces, which is FQR and W, which is 60 degrees. So FPQ upon sine 60 will be equal to W upon, when you look at W, we have to look at angle between the other two forces, which is FPQ and FQR. So the angle is 30 degrees. So this will be sine of 30 degrees equal to FQR upon. So when we look at FQR, once again we have to look at angle between the other two forces, which are FPQ and W. So one can see that we can look at this angle, which is 90 degrees. But then that angle will be cutting through FQR. So the angle that we should be looking at is this 270 degrees. So FQR will be proportional to sine of 270 degrees. So this is the equation. So we'll have FPQ equal to W into sine of 60 is root 3 by 2. Sine of 30 is half. So this is root 3 W. So we have FPQ equal to root 3 W. Similarly, FQR will be equal to W into sine of 270 is minus 1 upon sine of 30, which is half. So we get this as minus 2W. We get FQR equal to minus 2W. So for FPQ, we have the magnitude is root 3W. FQR, we have magnitude is 2W. So options A and D get eliminated. The answer will be between options B and C. Now what is the difference between these options is the nature of forces, whether it is tensile or compressive. So for FPQ, we have got a positive value. The positive value means that the assumed direction of forces is correct. So what we have assumed is correct for FPQ. Now what does this indicate? What does this direction of forces indicate? This indicates a member in tension. We have marked the internal forces for PQ. So this is indicating tension in member PQ. So we have FPQ is root 3W, which is a tensile force. Now for QR, we have minus 2W. Minus indicates that the assumed direction is wrong. So the actual direction for QR should be something like this. Now the green one indicates the member in compression. Once again, this is nothing but the internal force that is set up in member QR. So this indicates compression. So this is FQR is nothing but 2W, which is compressive. Right? Minus indicates that the assumed direction was wrong. So the actual direction will be opposite. And the green one indicates it is in compression. So we have FPQ is root 3W tensile, FQR is 2W compressive. So the answer will be option B. You can also think of this question in an intuitive manner. Like you can visualize if we had some bracket like this and we had applied a force which is like this. So this member PQ will be getting stretched. So this will be under tension, whereas this member will get compressed. I hope you can visualize this, right? So the answer will be option B. A truss is composed of members AB, BC, CD, AD and BD as shown in the figure. A vertical load of 10 kN is applied at point D. What is the magnitude of force in kN in member BC? So we have to find the force in this member. So if you look at joint C, we have two members and we will have one reaction. So at joint C, we will have three forces. So we will be able to apply Lami's theorem at joint C. But before doing that, what we will do is we will find out the reactions. So this is a roller support. So this is going to have a vertical reaction RC. And this is a hinge support. So it will have two reactions. But if you look at the diagram, there is no horizontal external load. So there will be no horizontal reaction. The only reaction will be vertical reaction, which is VA. So now once again, when you look at this diagram, we see that it is a case of symmetric loading. So both these reactions should be equal. Both of them add up to 10 kN. So each of them will be equal to 5 kN. So both of them will be equal to 5 kN. So now we have found out this force, we will be able to apply Lami's theorem at joint C. So we have at joint C, one of the force is 5 kilonewton. Now since this is towards the point, we'll assume these two also to be towards the point. And then we'll complete the diagram. So what you're doing is we are assuming the internal forces in members BC and DC to be in this manner. So we have at joint C, this is FBC and this is FCD. Now looking at angle, this is given to us as 45 degrees. So this is 45 degrees. This is 90 degrees. So this is 135 out of 360, 135 is gone. So this will be 225 degrees. So now we'll have by Lami's theorem, FBC upon sine of. So for FBC, we have to look at angle between the other two forces, which are FCD and 5 kilonewton. So we have these two cases, but then this angle cuts through the force. So the angle we should be looking at is this. So we'll have 225 degrees over here. The known force is phi upon sine of. So for 5 kilonewton, the angle will be angle between the other two forces, which is FBC and FCD. The angle is 45 degrees. So this is 45. So we have FBC will be equal to phi into sine of 225 upon sine of 45. So this is phi into sine of 225 will be minus 1 by root 2. Sine of 45 is 1 by root 2. So we get this as minus 5 kilonewton. Minus indicates that the assumed direction is wrong, whereas the magnitude is 5 kilonewton. In this question, we are asked the magnitude of force. So the answer will be 5.